Okay, so graph transformations is what we call the only a few actually what we call translations. When you shift the graph up, down, left, right, and reflect, with respect to x-axis or y-axis. Okay, and we have also dilations. You can dilate the x-axis or the y-axis. All right. Okay. Suppose you're given a graph of functions. Say x. Okay. So this is the graph. Looks like this one. Okay. And let's see here. This is y equal f of x. And you can shift this the graph up, down, actually x-axis, y-axis. Okay. Here you see the first one. Y equals. Okay. First, x naught is positive. Think x naught is positive. Or you can think this way. Okay. So this means what you translate is actually the axis. Translate the axis. Okay. So here, in the first one, you translate x-axis translate x-axis to the left. Why? Because you subtract. Okay. The thing is, if you translate the okay, if you translate x-axis to the left, then the graph looks like move to the right. Right? The other way around. Similarly, this is translate y-axis down. Okay, so when you move the axis down, that means the graph moves up. Right? So the on the opposite direction of the how the axis translate. Okay, so this is the same thing. This is translate x-axis to the right. This is translate the y-axis down. This means graph up. Sorry, not up. Right. Okay. This is this one graph move left. The axis down, graph move up, and this graph moves down. Okay. So give you just example here. Let's see. Let me just get something slightly bigger. Okay, this is all right. So this is the y equals square root of x. Okay, so let's do what if we translate up? This is wait, the graph moves up because the axis is moves down. Oh, sorry. Okay, so this looks like graph moves up, we move down. Okay, and this one. This is the graph moves to the right, meaning the x-axis move to the left. Okay. So if we have somewhere looks like this is let's see, move down. Sorry. The graph moves down because the axis moves up. Plus. Okay. And finally we have this one. So here is the graph moves to the left because the axis is moved to the right. Okay. So y equals that. Okay. So that's how you get the translations. Okay. What about the reflection? Reflection. So, okay. So if you have a graph that looks like this one, okay. So x positive becomes negative, x negative becomes positive. Okay. That means the one that reflects this way. Let's see. This is Right, so this is okay. So that means reflect. You can say with respect to y-axis, or you can, yeah. But you can have also that means it's the one I should write it here. Okay, so this is reflect with respect to x-axis. Okay. Um, I will postpone these dilations later until we get to the trigonometric functions. All right, so let's do this one. For example, right, this is an example. How to get the graph y equals as a transformations of y equals x. Okay, so how to get that one? So this one is x is positive minus x is x negative. Okay, so what it means is that for x positive or to the right, and you keep the graph. Okay, because you put negative here for x negative, and you should reflect. Okay, so we start with this one. So this is y equal x. Okay, so what this tells you, it tells you is that for x positive, so to the right, you keep the graph. So that means we keep this one. And to the left, you reflect this graph. When you reflect, this is what you get. Reflect. So this is how you get the graph of the absolute value. Okay. That way you can, so for example, is, so given y equal, so example of this one, find the graph of what about the absolute value? All right, so for example, the graph of f looks like this one. Okay, so this is y equal f of x. Okay. All right, so this one, let's break this down into f of x if f of x is non-negative, and if f of x is negative, then stick in another negative sign. All right. So what it tells you is that this is above x-axis. This is below x-axis. Okay. So if the graph is above the x-axis, you keep it that way. If AF is below the x-axis, so the graph below the x-axis, then reflect. Okay, let's do this here. If F is, let's see, which one's above? This one's above. So we keep it this way, the green one. But if that's negative, all right, so below the x-axis, this one, reflect. So this is what we get. Okay, so the green one is absolute value. Okay, questions? All right. So now you can make this well, we'll do this later. Right. Okay. This is parity. What is parity? Parity is about odd or even. Okay. A function f is said to be even if equals to this one. Okay. This even. This is odd if f of negative x is, you somehow can factor the negative out. Okay. So let's see here. What it tells you is that the this one, x is the same as the negative one. So that means this is what you call, this is symmetric with respect to y-axis. So to the left and to the right of y-axis, it is the mirror image. Okay, so the y-axis is the mirror image, the mirror. So the graph is the image. Okay, on the other hand, this one, let's see. This is the negative of the of f here. Okay, so this what is even. So even is easy. So if this is known to be this way, for example. Okay, so if this should be even, and then the to the left, it should looks like this one. So this is even. So you see that this is a mirror image. Okay. And what about the odd one? Well, the odd one is uh, this one here. For example, if you have odd one, say, looks like this one. Let's see here, for example, this is 1, this is 2, this is 3, for example. All right. So what about the value at -1, -2, -3? So this should be the negative of what we have here. So what we have here is that this is positive, so this should be negative. This is negative, so this should be positive. This should be negative. Okay. So what you have the left hand side is just you reflect this with respect to y-axis and then reflect to the x-axis. Okay, so that's how you get the even functions. Sorry, odd functions. And the thing is, why is we have the term even and odd? It's like like numbers, odd or even. What has to do with odd or even? All right, so let's see here. So why the term even, odd? Okay, so let's see here. Let's check the function. Okay, so let's check that. Let's check. When you check functions even or odd, just check this one. F of -x. And let's compute this one. This should be. And this is negative of f of x. That means this is odd function. Okay. If you see the picture, the graph, there. Okay. All right. So what about this one? F of absolute value. Check here. Plug in -x. That means absolute. But absolute value of -x, right? That's the same as this one. So this is equals f of x. Okay. That means this is even. And maybe without the graphics mirror image with respect to y-axis. Okay. What about square? Okay. So let's check. F of -x. Okay. So it becomes, let's see, negative x squared. But the negative will disappear anyway. So let's give you, this is even. Okay. So you see the graph, symmetric perspective. All right. And till power 4 to give you an idea. Power 3. Okay, so plug in negative x power 3. Okay. Well, the negative e power 3 is still negative. So this is negative of f of x. So this is odd. Okay. In fact, if you power 4, then you need to check. Negative 1 with power 4 is positive. So same as this one. So this is even. All right, so you get an idea where the even odd term comes from. So this will from the exponent here. Okay, so x to the n, right? So that's really depend on the n. Like a negative x. Okay, so this negative 1 upon n and x to the n. All right, so that's really depend on the n here. If n is even, so this become 1. N is even. When n is odd, so this is negative 1. Okay. Here you have f of x. Here you have negative f of x. So this is n odd. Okay. All right. Okay, up to this one. Let's see here. What about the arithmetic even odd functions? Another example is okay. Let's see here. This is odd even. Not. Okay. We'll see. Let's check this one out. Plugged in negative. If you plugged in negative, you have, okay, and plus 7. But this is the negative drops out, so you have the negative drops out plus 7. So it is still as the f. So this is even. All right, and if you look at the component here, this is even. This one even. And this one, well, this is also even. Not the number 7 is even, but you can think this is as 7x to the 0. Okay. So constant function is even. Okay, so this is a sum of even functions. Okay, so this is general. Let f and g even functions. So let's see. What about f plus g? All right, so let's check here. F plus g, and then plug in negative. So what we get is this. But because f and g is both even, so it is you get f, here you get g. So, so this is still even. Okay. What about f times g? F times g. Oh, plugged in negative. So you get, let's see, f of g of negative x. All right, because g is even, so this is the same as g of x. Oh, sorry. This doesn't mean composition. So mix it up with composition. Sorry, this is f times g. Plugged in negative x times g of negative x. But both are even, so this is f of x, this is g of x. F times g, so this is even. Okay. All right. So with the, but with the this multiplications, okay, sorry, f and g odd functions. So let's do, so the question is, what about f plus g, f times g? You just check, you can check by yourself. This is gonna give you odd, but f times g, let's see, like the negative f times g. Because f is negative, let's see, f is odd, so this becomes negative, okay, and g is odd, so you can factor the negative out. All right, so negative negative drops out, so you have fx times gx. That means this is even. Okay, so if you have multiplications, you sort of have something like looks like this one. Multiplications. Multiplication of even or odd functions. Okay, so even times even is even. Even times odd is odd. Odd times even still same. But odd times odd is even. Right? So this is what's the uh, what gives you difference with the multiplication of numbers? That's because odd times odd is odd with the with numbers, but this gives you even. Okay. Questions? And what about with additions? Well, if f is even, g is odd. For example, what about f plus g? And then give you there. G is f is even, so this is f of x. G is odd, so this becomes negative. So it's not the same as. So the conclusion is that f plus g is not even. But this is not the same also as this one. So the conclusion from here is not odd. Okay. So you cannot mix them with addition or subtractions.